This is our audio system. It's comprised of a transmitting circuit and a receiving circuit. Both of these circuits must be powered with only one 9-volt battery. So here's our transmitting circuit. It has three main parts. The first is the mixer, then it goes through an amplifier, then finally it goes through a summer. The mixer takes two signals, one from an iPod or other music playing device, and then another from a microphone. So the microphone requires a 5-volt source to function, so we created a voltage divider to apply only 5 volts across it. Then the output of the microphone goes through a capacitor and then is fed into the amplifying circuit. Now the audio input also goes into the amplifying circuit. It goes through a capacitor and resistor first as well, and this is to make sure that the signal coming into the amplifying circuit from the iPod and the microphone are both equal. We have them around 10 to 20 millivolts in amplitude each. So now we have the amplifying circuit here. This is really just a non-inverting op-amp with a gain of 10. It wasn't necessary to use a non-inverting op-amp because when you have an oscillating signal used in audio, it doesn't really matter whether it's negative or positive. So we used fairly high resistor values in this circuit, and that's mainly to make sure that when the signal goes through the capacitors that are connecting each circuit, that they don't create a high pass or low pass filter that really filters out the audio signal. So finally the signal goes into the summing portion of the circuit, and this is basically a bias T. What this does is sends an DC input through the inductor right there, and then that's used to apply a DC offset of 4.5 volts to the signal, and that's going to power the laser. Then we also have a capacitor, and that prevents any of the DC voltage from flowing into the AC portion of our circuit. Likewise, the inductor prevents the AC signal from flowing into the DC source. So then that's connected to a laser. As you can see, the positive is connected to the shell of the laser, while the negative is connected, the ground is connected to the spring inside the laser. Now here is our receiving circuit. So the input is a solar cell. Now this goes through a potentiometer to control the voltage, and then that goes into a capacitor, which serves the purpose of removing any DC voltage that is created by the ambient light that goes into the solar cell. Now this is the standard, the design of this receiving circuit basically just amplifies the signal so that I can power the 4-watt speaker. It uses an LM386 audio amplifier, and it's set up as according to the designs of a gain of 200. However, we added a resistor here where the signal goes through to lower that slightly to around 160 or 170. And so then that goes into the speaker, and you hear the output of both signals. Here we have the transmitting circuit set up, and I'm going to go over to the receiving circuit and show you how it works. Now we just have to plug this in, and here you can hear the audio. And that's because the signal is getting transmitted through the laser right here. So now we have the iPod playing into the microphone, and we're going to go over and see how that works. And so here, we're still getting a pretty good signal out. And you can adjust the volume using the potentiometer right here. So the volume's all the way off now. Thank you for watching.